All right, let's begin. Welcome all. I'm Nikhil. This is my founder Gokul from Signler. We wanted to do a little more than a pre-placement talk today. We wanted to really welcome you all to our laboratory and also tell you about our story. What are we really solving? What is the opportunity that we're trying to address? The big picture of what Siler really is. And that I'm sure will give you the right perspective to understand whether you see an opportunity in working for us or working with us, so to speak. So we'll not waste a lot of time. Let's go ahead get started. We will be sharing a presentation live with you. Gokul and I will take turns to discuss different parts of this presentation. Quick housekeeping, there is a Q&A section on the platform at any point in time. If you want to register your question, you can type that in. We have a moderator who will look at that question, and at the end of the presentation, we will take up these questions, and as much as the time permits, we will be able to address as many queries as possible. So great, so let's get started.
Once again, welcome all, and without much delay, let me begin with our journey, right, and story. This is actually a very famous ad that came in our 90s and early 2000s. And what you saw here is not about Motilal Oswalt, right? What you saw here is a sequence of actions that we keep seeing, and the whole world that is built beyond the software that has been built or the desks that we actually sit in, which is a lot of coordination between the eyes and hands, right? The manual labor. Now, if you just look at manual labor again, across all these variety of tasks that we actually saw, right? Be it putting parts together or wires or your warehouses and whatever that you might actually think about, from a construction to your food processing to anything, you see that people are constantly doing these three actions, right? If you just break all this variety of tasks, right? It's just picking, orienting, and placing, right? And you always hear automation as a word associated along with it, right? And automation has been prominently being spoken about. That's the basis of most of engineering that we actually do. And the world hasn't been quiet about solving this. This has been quite well known as a problem and active field of study always. And we have progressed significantly, right? We keep hearing about how AI is today and how our Google AI is able to dream, right? And we have seen robots from Amazon's Pick Challenge helping in the warehouses to do the last mile, the pick and place of the objects, and then packaging systems, right? And we also have seen obviously the star of all the robotic arm, or sorry, the robotics world, as it's the Boston Dynamics and things. This was a very positive narrative that we had, and people had been actively talking about how AI is going to rule the world and how it's going to take over most of those portions, right? Which is really great. But suddenly, after a few years, a lot of story has changed. The perspective has changed. Suddenly, the doomsday has been moved over and then been spoken more about how we are not there yet and how limited is our automation. It might be a lot of hype, and we may not be there yet, right? But in fact, if we have to statistically understand this, right, beyond what we actually hear, because we are surrounded with a lot of different perspectives and opinions, right? If you have to just step a little bit into the statistics, right, The 2017 McKinsey report clearly states that around 31% of the time spent, it's about the time that has been spent. What do we mean by that? To make a product, you have variety of different tasks that happens on a day-to-day basis, right? So if you go into a manufacturing plant, and in fact a precursor to that, if you just look around you, every object that you actually utilize today, right? Be it the food that you eat, to the spectacle that I wear, to the shirt that I actually put, and the things that I've consumed all through the day, including the water, has come out of some portion of a factory today, right? And if you just look at them and how that has been segregated across, right? There are multiple different variety of tasks that happens, from decision making to expertise being applied to data collection to data logging to observations, and then the physical labor, right? Where someone uses their hand to perform all of this. Our eyes and hands, coordinated eyes and hands to perform all of this, right? And logistics for the case. So that is more than 31%. That's the largest chunk across every domain, right? Be it manufacturing, be it agriculture, be it transportation, right? Accommodation, whatsoever it is, that the human hand's presence is very high. And if it's just boiling down to the human hand, and then like we spoke about picking, orienting, placing is the task, we have obviously heard about robotic arms, right? There are so many robotic arms that typically are in the market, and we also have seen many videos of how those robotic arms are able to operate and then they're able to solve certain applications. But on the other hand, if you look at the size of the robotic arm, that's also not a small market. It's almost a $16 billion market, right? And what is more surprising is those robotic arms also need a lot of engineering around them. Somebody will have to go and do the programming, somebody will have to assist them, right? They are not like out of the box that you can actually keep it there and the system kind of learns and starts doing that in spite of the AI that we actually have, right? But that is the $32 billion, which is very healthy and quite significant. But that kind of pales when we compare with what's the size of just US market alone that it pays in terms of manual labor wages. And this is the most actively seeking, one of the most actively automation seeking markets, right? We can only imagine about the rest of the other countries like China and India and Japan and Europe and most of these places, right? And of course we have the data only for the US, and that's 1.27 trillion dollars, right? But that also brings another question. Could it be, how true could this be, right? How hard could it be, right? What is the perspective or the proportionality of the automation that happens, and where are we stop, right? Instead of me speaking about it, I'll let the person who managed to bring the rocket and then land it back on Earth, right, speak about it, right? So if you just look at the man who managed to do the land the rocket back, kind of.
But here you can get a good sense for. There's like General Assembly is what I was talking about as being really well suited to people.
Okay.
Because you got a lot of weird things that you got to put together. Like, you know, like look at some of these, you know, assemblies that like it's pretty hard for a robot to like connect this on.
That makes sense.
Yeah, it's, you know, like depending upon how it comes out of the box, it could be like in a little different position. But it's pretty easy for somebody like, oh, it's like I just need to move it like an inch. You know, bolt it in.
It's probably really hard to write software to kind of know to adapt in all these different ways.
Yeah, so if you try to have the robot do this, you got to have like a complicated vision system, and then like the vision system faults out. It's like it's not quite right.
That's the hard part. We have a robot in our studio that moves the camera around, and the hardest part is when it faults.
Yeah.
You need a person there to know what to do.
Exactly.
For a man who managed to make an electric car which was invisible for almost 100 years, right, as a technology to percolate. On the other hand, technologically, something advanced for you to even land back the rocket from space. This seems to be a hard problem to solve. In fact, that was reflected very well in his sequence of statements, right? In 2017, he had the Model 3 that has been released, and he had bookings over and above several hundreds of thousands of bookings that happened. And he was gung-ho, Elon Musk being Elon Musk, that you know, we would be able to automation. I'm exposed to the level of AI that is there, and automation is something that we could do very well, and we should be able to address this demand. But a year later, they happened to do only 30,000 parts, right? 30,000 cars that they were able to release. And in fact, Elon Musk came out and then said that we underestimate the human capability, and we kind of overestimate the technology that exists for automation, right? And in fact, this tour that he has actually taken to his factory to explain what is actually hard and what is that the robotic arms are good at today, right? So as a part of it, right? So why exactly is this too hard for us to put together these weird things, right? So to study that, maybe we'll have to look at each of the stars that we actually saw before, right? I mean, it's all about picking, orienting, placing, except that it's not just the hands that are doing the picking, orienting, and placing. It's often the scenario in which they are supposed to do the picking, orienting, and placing, right? Your environment is constantly being put into an unpredictable scenario, right? Behind these clean manufacturing places where you are actually doing all this precise placement of components and things, someone have to pick from a clutter from which they have come. If you have to do all this clean wiring and things that you have to do, the wires are always entangled. How do you understand how to put the wires together, right? And all this clean stack arranged warehouses from which the robotic arms can actually pick, if at all if it is arranged, behind them is this complicated scenario of all these plethora of the objects coming from their native places. From logistics, when they come inside, they are not going to come and arranged, right? And it's too hard for us to keep them all arranged, right? Even the way those things would be, even an of variations becomes a hard problem today, right? So they are all in unpredictable and cluttered environment. Now, if at all, to just see how the automation could happen for all of these things, when you have to kind of structure them, right? Here is a picture that is there on your screen. You can recognize the playstations that are there, and this is a PlayStation automation, assembly automation, where someone is manufacturing the PlayStation together, putting together the PlayStation. And if you just see that there is plethora of apart beyond that easily recognizable PlayStations, you also see a very complicated myriad of sensors, mechanisms, contraptions, right? Wires running through here and there, and each of this needs a phenomenal amount of engineering design or mechanical design that you have to do. The corner portion where you see, this is basically your robotic arm at the base, right? This is all your different kind of sensors and complicated engineering first. What could this be doing? Obviously, this has to be something for very complicated activity that they must be doing, right? Unfortunately, all that they do is just flip the PlayStation from a horizontal position to a vertical position. This simple action today actually takes so much of hardware, right? That brings another question. So if a robotic arm is there, why can't that guy go about directly picking that from there, right? So in fact, this is one very nice scenario, right? So if a robotic arm have to go and directly pick from there, here is a image from one of our customers where they have implemented it. So you see this blue color robotic arm here, right? So this is the robotic arm which is hanging from the roof upside down, and this is a processing machine, which is a CNC machine typically, right? Into which the parts are being fed into, right? And you have all these parts coming here, right? So this fellow will pick from this table these parts, which is engine casings, right? And cylinder casings, sorry, and they will be able to present them into the CNC machines for the processing that they are supposed to do. Right? These are the cases where you're able to automate it, for all you're able to put a robot down. But behind that scene, right, what actually happens is this. There is a person who is actually picking those parts again from within those bamboo structure that has been put, and then he has to arrange them on a pre-built, customized conveying system, right? And the conveying system again goes and presents to the robotic arm. Obviously, that brings a question: why can't a person just directly pick and place in there? It's just about the amount of okay that you can put in this case, and how well and how organized could they get into in presenting these parts, right? So we need predictability and the precision. That's the major driver of robotic arms today, or the automation today, but they're still not yet there. There are some parts that you would not be able to put them in those arrangements and things, right? So without much delay again further, I'll again give it to Nikhil for next portion about what actually is behind it, what would take for us to build these systems.
Right, so getting robots to really grasp a variety of objects and do tasks like how human beings do is not like a problem that we are articulating for the first time, right? It has been a dream for the world of robotics to always do this. In fact, for ever since the first robotic arm was launched, probably 4 or 5 decades ago, we've been imagining that eventually robots will be able to do that. It's just that it has turned out to be such an elusive problem for the industry to solve. And for us to understand why it is so elusive, we have to go a little deeper into understanding where tech is today, how tech has been approached all this while. if you really look through the internet, you will see that there are quite a lot of players, and a lot of these players use different kinds of vision technology, but predominantly everybody rallies around 3D imaging, because you're living in the 3D world, you need to go grasp objects in the 3D world. So 3D imaging is required. You can construct 3D images using stereoscopy or different kinds of mechanisms to construct 3D depth map, and the assumption is that that is enough. But the challenge is that all of these 3D imaging methods gives you a fairly sparse depth information. In fact, the information that you get out of depth image is even lesser than an information you'll get out of a 2D color image. And because of this sparseness, what you're able to achieve at best is you're able to only work with simple geometry objects. And even when you're working with simple geometry object, you're only able to approximately locate an object, go touch that object, and you assume that if you touch that object sticks to the gripper, and then you can go somewhere and drop it. The moment you drop it, you lose the orientation of the object, right? So all of these solutions at best can do a touch and drop kind of a scenario, which is okay if the application is to sort from a randomized bin, but you cannot build a car, let's say, by dropping 10,000 parts at each other, right? When you're building a car, you need to pick every single object and then reorient and place them in very specific manner, pick boards, reorient and place those boards and assemble them very specifically. And the current solutions don't really scale to doing that, right? And again, from a methodology point of view, all of these systems, even if they're using vision, follow this typical paradigm. What you do is you acquire images, either 2D or 3D images, and then you train a neural network with a lot of static images that you had already previously obtained. And with that, you're going to train a neural network. And what the neural network can at best do is localize where that object is, probably draw the boundary of that object. And it is assumed that that kind of information is enough to give to a robotic arm, and then the robotic arm later just figures out how to go and pick, right? And this is fundamentally flawed. This is very different from how human beings work. Human beings have a lot more dynamic capturing. If we don't have the right kind of information about an object, we move, right? We look around, we are able to hold the object, pick the object, etc. This existing paradigm is also limiting because the vision and manipulation is assumed to be decoupled in this case, right? So the vision training happens separately, robot training happens separately, whereas human beings don't do that, right? Human beings, as a baby, we start hand and eye coordination is learned hand in hand, right? And that's how we really learn when we are picking an object. We learn the object after picking the object, right? And that's something that we have as an ability that is unique. And most importantly, the assumption is that the world of vision is all about interpreting color, right? And that's a obvious assumption to make. Don't we see the world only on color, right? We interpret colors and we classify objects in the world through color. But to elucidate that probably is not enough. If you look at a cluttered scene like this is the scene of a market, there are so many colors, right? There are so many hues and shades of colors. If we went about classifying objects in what we see just based on color, these are the number of objects we should ideally be seeing, right? And in fact, at the earlier layers of our vision, we actually classify objects these many. But somehow our brain is able to interpret this complex cacophony of colors into these specific objects. The yellow and blue in the umbrella is classified as the same object, while the yellow in the flowers are entirely different. And how are we really doing it? There are fundamental layers that are beyond, and to elucidate one such layer, which is very, very fundamental, one more quick optical exercise, right? So what you see in this image or this slide is 3 images. And I'm telling you that in each of these 3 images, there's an animal, right? And each of these 3 images, the animal is at a different location. And if I ask you to find out where the animal is, it's very difficult for us to do that. We are constantly searching, we are looking around. And the reason it's so difficult for us to see is because the animal is camouflaged with the background. When I say camouflage, what I mean is that the color of the animal is probably very similar to the color of the background, so it becomes very difficult for you to see. So in the colored domain, you don't have enough information to understand where the object is or where the animal is. But the moment I show you the animal in motion, if you see the 3rd image at the bottom now, what you really see is so what you see now, you're able to identify where the animal is, right? And we're able to identify the head and the tail of the animal. And that's because we as human beings have something called as event imaging or temporal imaging, which allows us to extract information that are changing in the scene even if that information is not particularly significant in the color domain. And that's a fundamental layer that we have implemented with our vision system and our robotic system as well. And in this demo video, what you'll see is our robotic arm picking an object, and what you will see on the top left is the robot setup. It is designed to pick a mirror finished spoon. What you will see on the right when I'm pointing my laser is the event imaging output, and what you see at the bottom is what the camera sees, and then what a standard edge detection algorithm would really see. And what you will observe here is that we're able to extract information or the output of the spoon, which is a mirror finished spoon, effectively from the background. Even though the background is a fairly cluttered cacophony of colors, right? So if you just look at this portion of the video, you'll see that the background is extremely complicated. Standard edge detection algorithms don't really work, right? It's extremely difficult for you to extract, but the event imaging algorithm allows you to extract that fairly well. This is not just enough, right? Like when you're really dealing with objects in the real world, there are a lot of other parameters that the system must cumulatively learn. Color is not the only information that one learns. To manipulate an object, you need to learn the shape of the object. You need to learn the size and the rigidity of the object, whether it's a squishy object or whether it's a solid rigid object. What is the surface parameters of the object? Is it a very smooth object? If I'm picking the object, is it going to slip or not? And most importantly, also at any point of time, understand the location of the object. You also need to understand the orientation of the object, and this orientation is the most difficult part, right? Because the moment the orientation of an object changes, as you see in the last image in the series, the shape of the object as you perceive it constantly changes, right? So for any complex object from different orientations, you have infinite possibilities of shapes, and that makes it a perpetually challenging, a perpetual training exercise if you really go about training for every single orientation. And this is one challenge that the world of automation has not been able to solve. So far, we've been focusing only on understanding color and location. And with that, you can do a few set of applications. But the moment you start learning the entirety of the object model, we will be able to solve use cases much more complicated. And to just give you a very quick glimpse, I have one demo video in the next slide. But fundamentally, the technology that we have built is a hardware layer on the vision side, which closely mimics the human eye. So we have autofocus optics and convergence, which allows us to move our eyes towards and further away from each other. And with this, we're able to interpret the different parameters of an object. We've also ended up building the world's fastest and highest resolution depth perception system in the process. We also integrate this vision with touch and force sensitivity. So we understand the physics of the object more than just the visual parameters of the object. And because of these layers, what we're able to do is grasp objects or do tasks on objects that were previously not possible. In this video, again, on the left part of the video, you see one of our team members playing with the robot. He will be presenting different objects to the robot. On the top right, you see one of the cameras, what it sees, and the bottom right is what the event imaging algorithm really sees. And you will see here that the robot dynamically tracks objects. Even if the background is fairly cluttered, you see people, you see different kinds of objects, this background is constantly changing, but still able to track the object. And the best part is that none of the objects that are being presented to the robot today have been previously trained for. The robots have never seen these objects, but still we are able to do basic grasp, regardless of what orientation you're giving, even if it's a mirror finished part, or even if it's a part like this lace packet, which is very flexible. It knows how to adjust the force and not really pop the packet out, and that we're able to do because of how we interpret these objects. We have a hierarchical way of interpreting depth, and also event imaging allows us to extract information out of the background, only focusing on the changes. With this technology, you can open up a lot of possibilities, right? So on how this technology will become very, very fundamental in opening up a new paradigm for automation, I will hand it back to Gokul to talk about how this is going to be the genesis of the future of robotics.
To bring about a vision of what this could do. Okay, so there is a robotic arm, there is something that is actually having as a vision system, and probably most of the details of it. we will understand much more in depth once we come inside, once get the exposure to it. But what can it actually do? What is this manual labor change that we're talking about? What is that we are talking about from a manufacturing point of view? Right? So to understand that better, I seek the help of an analogy, right? So in fact, this analogy is pretty much true and very closely or related on the basis of physics, as fundamental physics, right? We have seen the world that we know today, right? So all of us are programmers, all of us use laptops, all of us use a lot of different items around us. And data is the biggest talk that we have today, right? The next oil is data is what people actually keep talking about. And if you look at it, they all begin in the format of signals. Right? Somewhere or the other, it's a real world signal that we have captured, converted them into whether it's a touch, somebody's thought being typed out as a physical touch onto your laptop, on your keyboard, or me talking right now. There is a video of us. That's light as an information, sound as an information is coming through all of you when you are actually having a live event that's happening. So all these signals are being captured in different formats and they're being converted on using a tool which kind of processes and converts them right into your ones and zeros and data, right? So and that's being sent to a very common platform, right? All of you might have a very different laptops in your home. I have a very different laptop in my home. Right in my place right now, I'm having an iPad that I'm using. I'm having a laptop that is actually hosting this, and each of them are all different form factors. Yet they're fundamentally very similar as a system. They're standardized. That's how the same data is being interpreted and then being consumed on the other side. Though the generation point is entirely different, right? The kind of camera that I'm using is very different, right? And you have how is that happening? First of all, we have a standard hardware platform on top of which we also have invented the code layers or program layers, which are abstracted, which is able to enable them across multiple devices, right, to run or interpret this data. With this, what you are getting is something that is meaningful, something that is utilitarian, something that you could use and then have some understanding about it, information, right? So this is getting all processed, converted, and then formed into an information that you might need at your end, right? The same way, can we imagine all this variety of different objects that we actually had, right? So all this variety of different signals that we had, a touch, a physical force, keys being put in there, voice being there, light being there, ones and zeros of various formats being there, all being processed by one simple single system as a combination. And you need all of these parameters together. Similarly, if you just think about a variety of different objects, right, that we might have, we first have to form a model of those objects, just like you formed a data model of your signals, right? That is overlapped with the standard set of tools sitting on top of it, right? And we have something called as a work model that actually comes, right? So I had tools on one side, which is my laptop. I had signal on the other side. Your program is nothing but how they both must interface with each other. If they interface this particular way, it will lead to my meaningful utility or my data or information altogether, right? So that exactly is what as a sequence that happens typically in your object processing unit. Just like we have a central processing unit, if you have these actions that is performed, which is a standard thing that is happening across any task that you take about you cooking something where you're cutting vegetables, you're taking vegetables are nothing but your objects that you want and the tools that you use to cut it, and the pans and things that you actually use are all your things, and how to operate on top of them, and then that becomes your meaningful dish at the end of the day, right? What you wanted as a final outcome at the end of the day, right? Or you wanting to pick a pen that is lying there somewhere, and then you wanted to pick it and then bring it to your expected orientation, which is your hand that you're using as your tool, and then you're continuously writing, which is a work model that you're doing. The result is whatever that you wanted to scribe as a thought on your paper, it comes out as that, the paper on the ink with a meaningful pattern on top of it, which you could interpret, right? So every task if you take seems to be very commonly broken or can be structured. If it can be structured this way, right? What kind of transformation can we actually see, right? This is very interesting, right? We have seen in 1980s and 70s and probably early 90s, right? How many different devices that we actually had for processing every variety of information that we used to have. For calculating numbers, we had calculator. For sending a data as a document, we used to have a fax machine. To make a copy, we used to have a Xerox machine, right? To have, we had calendars, right? We used to have gramophones. We used to have telephones. We used to have radio. We used to have television, right? Imagine all those devices being blended into just, why did we have, first of all, why did we have all those devices? Because each of them have very different data. So if I had a very different data, very different signal, then I have to have very specific devices to it, right? But the moment they have been merged into one particular laptop or one particular device, somehow we figured out how to do that. And that transformed the economy that we have today. They transformed the world as we know today. The possibilities today, we are just, I'm sitting here and then you are sitting somewhere else. And then we are conversing about how you are going to join this company and what could you do here. This would have been impossible in 1970s or 80s or 90s or even in 2000s, early 2000s, right? This has become so phenomenally possible because we were able to generalize the laptops, generalize the system. How did they do that? They kind of understood that first I need to make a model of each of the data, and all data, if I see, performs only two tasks. One is arithmetics, the other is logic. What does arithmetic do? It removes or adds something to your data, whereas logic is just routing them between these actions in a repetitive sequence, right? They say it's an arithmetic and logic unit. The moment I am able to bring that and the supporting ecosystem standardized, I was able to build a CPU, and that became the genesis point of your laptops and computers, which could become a common form factor or a platform, right? We are at the same genesis for an object, right? In fact, if you think about an object store, just like you have an app store today, what could I actually have in that? First, I can form a model of object. If I have learned one bolt somewhere in one place, right? I have a digital representation of that model into my system, right? And I own that, right? And if I also have to make a model of those tools, then I can actually form another model called work model, right? So this is basically your how whenever I see that particular bolt, I see that spanner head, where should they actually make? How should they actually make? Because after I make the object model, the task that I would do might be very, very different, right? So this is a combination. Extrapolate this for a scenario of a food. I'm just making one example, taking one example of food, right? Let's say you visited Indonesia, you visited Thailand, you liked some curry, you liked some dish over there, and that guy has set up a restaurant and he's so unique because he has figured out a recipe, not because he knows how to cook. If he knows how to cook, he would have become a chef, right? He's opening up a restaurant because he has a unique taste that he has actually invented. What is the taste? The taste is nothing but a combination of your objects and the tools that he actually uses on top of them. And how do you operate the tools on top of it? Did I put the masala first? Did I put the pan next? How much did I heat the pan? How long did I keep it on that? And how did I do that? This is all work model that you have. You have these combinations. Imagine at some point of time, today with this combination is able to make the very tasty dish. But if you want it, you come back to India and then you don't have the restaurant here. And if you want it, the only way by which you can consume is either that guy will have to invest a lot, open up a restaurant here, put up people here, manage all of that, and then he has to serve you, right? Which means he has bare minimum number of customers that is needed. Or you will have to go again to Thailand. This IP or knowledge of something is not able to, like KFC does, you are not able to franchise it. You have to create a franchising model. Instead, if I had a laptop or if I had something like a laptop which you can just pass in like an email onto this, and then you suddenly are able to convert that into something and then into a consumable format, like a light and video that you're seeing. It can be a taste and food that you can actually eat, right? It is that perspective that opens up, right? That if you are able to invent something there, and he also has the robotic arm and the system in that place, and we also have a similar robotic arm set up in our home because it's affordable and cheap at one point of time, what could it actually transform into? How people will be able to create these things? You want a plumber, the plumber could sit somewhere else, you just have to, he will just guide you to position something somewhere. It's a science fiction, obviously, that we want to get into, but you just have a model and then you upload the model, and for his knowledge to be able to fix this, he could actually be remunerated without having to physically be present there. You could address a lot more customers at the same point of time rather than having to, with the skill set, rather than his skill set being localized because of his demand to be present in that particular position, right? So these are phenomenal, explosion of value that you could actually create in this case, right? With this, there are other ancillaries that would happen today, right? Today we don't search on the basis of objects, we search on the basis of what we have as color, right? And what, because at the best Google has come up to is images, that you can do an image search, right? Or a voice search. But when do we get into an object search, right? What do I mean by object search? You go to an Amazon today, you are trying to buy certain items from Amazon. What do you see at the bottom? You see all the associated products that you can buy. On what basis do they populate that? They populate that on the basis of how many other people and what pattern did they buy along with it, right? But instead, if you want to say that, hey, I want to see all the bags that are textured this way, which is soft, which is a velvet cover, or the zip of this sort, right? That's something that's not feasible today, right? Could I search the parameters of the object as I could describe it, right? To do that, what is lacking today? Because most of these NLP systems do not understand verbs. They can understand nouns, right? But they have never experienced verbs. They don't know what it means to catch a ball. They don't know what it means to bounce a ball, right? If I apply this way, will it bounce more or will it bounce less? This is what stops them from having a conversation, right? Otherwise, you're just borrowing words and then just filling in patterns of sentence making, right? You're not making a pattern of how it could be imagined. If I'm saying a barber cutting my hair, how is he cutting the hair? What is it cutting hair means? There are a lot of subtleties of details that they cannot imagine today because they lack understanding of verb. Why do they lack the understanding of verb? Because those systems cannot go and perform any task typically, right? It can now, if I'm able to understand verbs, it extends also towards drivers with cars because I can understand motion and movements, right? So just like we had, even imaging in this case, right? That also further extends to what you could do from an AR, VR perspective and what you could do with an immersive entertainment perspective. Imagine you could walk into a movie. Instead of you having to see the movie only in one perspective, right? One vantage point, what director shows. What if I want to just go there and then in one time I want to see like that particular character, how the world is, right? In another time I just want to see how the other world is, right? This kind of makes a movie, even a single movie, to be a lot more explorative and a lot more possibilities to be built in an alternate world. In fact, recently this metaverse has actually started coming as a point, right? So that's something that is quite interesting for us to again see where that would get into and how we could contribute to that sector as such. Right? If now we look at this, how disintegrated this robotic arm market was with our product, maybe we could have simplified this into one unified market where people don't go about customizing and building it, but they can off the shelf buy this robotic arm as one system and then start programming on top of it and start deploying it. But beyond that, also often when you solve something like that, when you standardize it, there's a larger market it opens up. Even outside of China, we have $80 billion market that actually opens up, right? So for us to do a lot of these activities, maybe we may not be able to do the kitchen thing today, but 10 years down the line, we'll be able to do it. But today we can open up a market, which is $80 billion worth of things if we are able to get this to the market and then start solving this. So that is the next big thing that we actually talk about. It's not just our words. In fact, we were able to, see what others might be thinking, right? What other stalwarts might be thinking from this point. So luckily enough, some of these things have been registered in the public forums. So in 2016, when Bill Gates was in Reddit asked me anything, when he was asked about what's going to be the next big thing, right? He goes about saying that robotic arm as good as a human being with a vision, which has vision as good as human being to be able to manipulate objects as good as human being will be the next big thing, right? And we underestimate that, right? Because this was an answer for a question when you was asked what's going to be the next big thing after this software boom and this OS boom that has actually happened, right? In 2019, again, Jeff Bezos also chimes in for the same point, saying that this will be the next big thing to open up into the market. So now is the part that I want to just get into. So we have been talking about what are we building and what is our vision and where we can get into, right, and what we can do. Now we want to again present to you how our work thing is going to be and what is it that we can offer and how exactly could we have the evaluation processes and what we seek as a skill set from you, right? This is basically our team right now. We are an 8-member team with some advisors in key positions that they have been very relevant to the industry and how we have been performing this. So all of us have different functions that we take into and we start performing. Some of them are in, there is a mechanical representation, there is an electrical and electronics representation, there is an algorithm and neuroscience representation, there is again C++ representation, right? So and there is a business operations representation, and we also have 3 of us, Kaushik, Nikhil, and myself. performing the business aspects of whatever that we do here, right? And we also have the advisors. So our first advisor again, Nalin Advani, is again from, he has been a grey orange ex-CEO for Japan and the East Asia region. And grey orange, if some of you might know, is one of the most lucrative or most successful India-based robotic startup which has gone global before. And he is advising us from several aspects of opportunities and the technology that we developed from. And we also have Dan Sula, again, who had been an ex-ABB, ex-Panuk, both from a robotics space point of view, and also being deeply entrenched for the past 35 years to 40 years in the automotive sector about applying robotic arms to transform automation there. And we also have Arvind Vasu, again, he is an ex-ABB ventures, technology ventures person. He also had been instrumental in setting up robotics, our robotic arm business in India for ABB, right? So these are our advisors now, and we also have some of our investors who have put their first initial trust in us and have helped us get to the point where we are today, right? So this is a day of work, fast forward format, that would be in our lab and what we have behind that you actually see how we would be working with our systems, right? So one interesting factor about how our work is, this is a confluence point of every engineering domain that you can imagine, and we kind of push to the depth of every engineering domain, right? Almost every part that we have is something that we have pushed to the technology owners of those parts. We have pushed to the camera people to do something way beyond what they would usually do for a camera, innovate something on them, right? Every technology partner who have come along with us, from cameras to the from the sensors, the image sensors, to the lens that we use, to the autofocus lenses and liquid lens that we use, to the wires and the cables that we use, to the motors and the motion control that we do. Everything the companies will have to get shocked and then look at it in a very different way, including the grippers and the sensing systems that we build on top of it. There's quite a bit of more work, a very large and deeper work that needs to be done yet, and that's what we are trying to get you into. What we have right now is a sample of what could happen under minimalistic system, right? What we imagine is a much bigger picture of how sophisticated a robotic arm and how human-morphic a robotic arm can get into solving the problems of automation today, right? So if you have to solve that, this is how many skill sets will have to combine together, right? I'm not seeing I'm not seeing just a robotics as a course would actually help in this case, right? So robotics as a course could expose us to what's happening as a basics, right? But we need the depth of each of these domains to come together, right? And often all of us might have to work in all of these things. For example, on a day for me, I would be working on mechanical design in the morning, and then again mechanical design can go up to how deep the manufacturability is, how your supply chain actually works, and what kind of CNC setup that they actually have. Often those guys won't agree to the parts that you want to make. They won't even, because they wouldn't have ever seen someone building or asking for this kind of. They build capacity and know-how only if some customers ask for those kind of parts, right? Often those kind of parts are not. Sorry, one second. So often those parts are not often those parts are not asked, right? The precision is never asked. It will be surprising and appalling if you just see how our mechanical structure is all across the world and how those things will be. So you'll have to get to the depth of it. You have to tell them how exactly that process could be done and how exactly that manufacturing could be done. From there you jump. Why are you doing that manufacturing? Because you might be facilitating the motion system, you are facilitating a kinematics of a motion system, you have to understand how motors might work, how the control of the motors might work. You have to again talk to the motion controls guys, and you might have to again build your own power electronics circuit that you might have to come from the basics, where it's okay that you have a lot of stepper systems and servo systems which you might have played around in your college as a hobby system, right? But actually when you get in there, it takes more than 6 months for you to get a particular motor to be tuned to get to the point where you want, right? So if I want to do it within 1 millisecond, so within 1 second once into a position, it's faster and easier, right? But if I want to get it at 100 milliseconds, it's pretty much feasible. But if I want to get it within 15 milliseconds, it becomes exponentially different, right? And you want to stabilize within the period of time, it's entirely different, right? That needs an immense amount of control understanding. And in fact, one thing that I want to put insist very strongly is, see, most of your engineering is all about gathering knowledge, right? In fact, the word engineering for most of you, just to put that point, if you just think about it, engineering doesn't come from building an engine, it comes from the word ingenuity, right? It simply means you're able to apply the knowledge that you have to build something that has never existed before, or something very unique in terms of value that never existed before, right? So that's what engineering is about. And what are you building? You're building a system. So how are you building a system? By controlling a system, because everything is picked out of the earth, out of this universe that we know. We are not creating new material anywhere, right? Everything is the material that we borrow from the earth, and then we shape them into whatever we want to bring that utility, right? How you shape them is the innovation, right? Basically, you're controlling the shape, you're controlling their behavior, right? Control system is at the basis of almost everything that you do, right? Your AI is, again, whatever the AI and things that we talk about, neural networks and things, are methods of how do you control the system, how do you bring that intelligence to control the system, right? So that's how it actually extends. So everything is very deeply interconnected from that point, right? So it's not just for the motion control and kinematics that you would do, it is even for the optics and the vision that we actually build. Everything is on the system theory basis and system understanding basis. That system understanding is something we have to have as a practice and thinking pattern, because today knowledge is not a problem because we can easily access it from Google, right? It's not understanding the fundamentals that are the issue. And every moving forward, every assignment that we would give, our evaluation process is all about extracting that particular capability of yours, right? We are not going to ask you knowledge-based questions, right? Oh, you should have known this, you should have known that, that system, this system, how Apache works, how Kafka works. This is for, let's say, for the computer science students or whatever it is, right? So, or how CDN works. We don't care of how those things actually work, right? What we care about is how fundamental do you understand from a programming environment. We don't care about what all different processes and how all that actually exists, right? We care about how fundamental do you understand your mechanical systems. How fundamental can you actually look at a particular, a system and then understand it from a physics point of view, right? Physics actually has the basics of it, right? And again, we have causal and observation things that we put, right? How do you understand your electronics? How fundamental do you understand your circuits? How fundamental do you understand the components of the electronics? Where do they actually come from? Where does your signal behave from? How does your signal come? The fundamentals of math, right? Not math as just equations and things. How do you want to relate to them to the physical world? So these are the things that we kind of explore in depth, right? So that's how your evaluation would be. Most of your structure in your questions and things that you would face will be structured around this. And often we also give a very detailed problem, and none of these problems that we give. So this is post your first your first engineering acting. That's what you would be attempting. The registration link that we gave for you to register. So those exams will be on Metal online test. That online test will be just puzzles. Every question and every puzzle have been picked out of the work that we had here. Nothing is taken out of internet or some pattern that we actually put here. It's only to elucidate what is the kind of problem that we face on a day-to-day basis, right? Sample of some of those problems. So you also get an exposure to what kind of problems that we might be facing. Every question is that, and it's a solved problem, right? It's not an unsolved problem that you're coming there. So that we also have a reference of how you're able to think, right? Our every question that we ask and everything that we have asked there is not to have a right or wrong over there, just to see how you are thinking about it, how you are approaching it, right? That matters more, because we also see that we would have to do a lot of training. Academia hasn't yet started doing what we are trying to do here. So there's a significant portion of it that we will have to again train and reinforce in those cases. That will be your internship period that will come. So post that, if you're able to get into the interview and then we are convinced with the interview portion that we are able to align well with you and you are able to align well with us, this is the problem statement that we'll give, because this is a more detailed problem, right? We don't believe in 15-minute questions, 20-minute questions within the time pressure that you have to solve something. Often most of the problems are research problems which will take a little longer, and if you're involved, you can go search in Google, you can construct the information that is there around it and then try to solve that problem that is physically there. Often the problem is not how to solve it, the problem is identifying the problem itself. Nobody gives you a question paper saying that, hey, this is the thing, just identify which equation to apply there and then start solving, filling in the equation over there and then try to get an answer out of it, right? That's never the problem that you face in your real world, right? Nobody's going to have a written question paper to you, right? Our first task is to even notice that there is a problem already there, right? And where is the problem? And often is it a problem or a constraint? And then get into it and start solving it, right? So often if you have identified your problem very clearly, then most probably you would have had the solution also for it, right? You know the problem only when you have solved it. That's how the thing is, right? So till then we have only an anticipation of the problem. We don't know the depth of the problem or understand the nook and corner of what the problem is, right? So for you to again go through the journey and then understand what that is, if at all, even if you're not able to clear it, at least you will be able to have a training on top of it, right? To have this process to go through as well, right? And if you are investing this much time, right? Typically, we also give a very detailed and involved report. This is how your report would actually look like. This is I'm saying after you clear your interviews and when you are getting into this evaluation problem point of view, right? So this is because we also see this as never an elimination round. Because once we know you, we track you, right? If not now, because we are also looking at we are for the stage that we are, we need to move very fast. We need to grow very fast. We can only spend so much time in grooming someone. So we also need someone to be a little more ready to us, right? But if you're not ready today, it doesn't mean that you're not ready tomorrow, right? You're not ready 1 year down the line. You're not ready 2 years down the line, 6 months down the line, right? So we will keep you in the pipeline. We kind of reach out. So one of the person again in the team, if you have seen Anton Makrushin, who immigrated again from St. Petersburg for a unique requirement that we actually had. He didn't clear the first round, right? But we again 6 months down the line, we followed up and he was able to clear from where he left from an evaluation point of view, and then he was interested further to come and join us, and he was able to get along with us and then move forward, right? So that's something that we always keep in, right? So this is only an exposure to see what we expect, right? And if you could also groom yourself outside the organization, not being part of UT or Singler for the case, to be able to build your skill set to be relevant to it, right? So I also want to just quickly jump to the job description, right? So some of you would have received, or most of you should have received the link to it. So if you haven't, if you had your WhatsApp link being forwarded to you or in your email, right? We have attached in both of that. If it's not being forwarded, maybe you can again get it from your placement coordinator at your respective universities to get these things. So this is your job description. So we have put that in detail about what we do and the skill set that you are looking at. So you again take a relook at it and then see wherever that you could fit. We are not expecting one person to solve all of this. Wherever your combination might come in, we will identify it and we will take them in, right? So you just have to have few portions of it. So which is what we have described here, right? You need to at least have one skill set in each of it, right? From a thought process point of view, and again from your skill set of engineering and application skill set point of view, right? And we are not so bothered about whether you know that language or this language, or you know that tool or this tool, or you're so adept in these things. We are looking at more fundamental understanding of things. We are a company who build the tool. We are the company who build the C++ or the layers of C++, not the ones who are using the C++ alone, right? We will begin with using it, but what we are aiming at is to modify things. We might even touch certain times to the compiler level to get certain things done, right? So you can have that in the mind, right? So when you're looking at these things, like I said, the evaluation process is going to be 3 stages. First, it's going to start with the online engineering aptitude and reasoning, right? That's how the questions will be, very fundamental questions from a physics point of view, and basics of, if you're a programmer, it will be basics of your system architecture. That's where it will again come from. And post which we will invite you for an face-to-face interview, and post which you will get on to that evaluation problem. The evaluation problem will will actually tell us where your actual strength is. It's a combination of multiple things. Whatever whichever aspect that you are able to solve it, that is the portion that we'll pick. And then this is to assess where you stand and what is that we have to train you with, what is that you are already having intention that you could actually learn by yourself in those cases, right? So that's how the evaluation is. The general criteria for all of them is these three, right? When we have the evaluation problem, we'll have very specific criteria. Mechanical is again mechanical oriented, electrical is again electrical machines and electrical perspective oriented, right? And electronics and algorithm is going to be very algorithm oriented, right? And for programming oriented people, we'll have a proper C++ coding thing that we will have, right? So these are different sectors and different classifications of problems that we're going to do, right? But before that, first fundamental thing in terms of alignment with the company, these are the three aspects that we actually talk about, right? Critical thinking, system thinking, and design thinking, right? Without having to explain this further, I'll let you read through it because I have spent enough amount of time or more detailed time trying to bring to the best of our capability to articulate what we are thinking about it. So you can take a patient look at it and then see how this process. Often it's not necessary that you already have it. You can also build this, inculcate for yourself. That's also something that we actively look for, right? And for anyone, don't bother about. If you're not able to clear from an engineering perspective, we also have a reasoning perspective. We also see other augmenting roles that might come, which we may not have articulated very precisely there, but we'll reach out back to you. So whatsoever the reason it is, it's better for you to just take that online test, right? So we keep you in the pipeline. We know who you are and what it is and who you might be standing in, right? So if thinking aligns, again, that's something that we would again look for, right? So from a career point of view, you will have to begin with an internship, which we highly recommend, right? Some of you, if you're not able to begin with an internship, then your probation period will become a little longer. Simply because the internship is not the period that we see that we could effectively have the candidates or our employees contributing immediately, right? There's a lot of things that we have to learn before we can start contributing effectively. So predominant time in our internship will be spent by us and the engineering team to transfer the knowledge to get you into the point where you could start doing certain things and break it down to small tasks, which will be a practice for you to get into bits, right? Then comes our probation, where you might also take some time for you to align with the organization, how the organization is thinking, what the processes are, why those processes exist, and the process are evolving. For a startup again, you won't have what is a process today will change in the next 3 months and another 3 months. It's constantly evolving as per the size. Because as more people come in, as more things come in and more volume of things are happening and moving, the process also will keep evolving, right? And the culture is something that we keep fundamental between these three thinking and what they even mean. Today you might understand the words, but once you are there, at least during 6 to 9 months to 1 year period, you will kind of understand what they meant as what. Because often words do not mean the same thing for two people, right? That vocabulary mismatch will also be there, right? That experience for you to again gain to align with ourselves is what the probation period is. Post which we have a unique format of inducting someone into your organizational, as an organizational contributor, which we will again discuss at length, probably during our interview portion or post offer with you or during the internship period, right? It's also a little more complicated how we do it to explain it. But what we see is that's the most fair way to remunerate rather than the way that typically most startups actually do. So that's something that we again wanted to highlight upon, right? So that is it from the job description point of view, right? So one thing again, I also wanted to add on to it. So I have already spoken about it. This is the feedback that we typically get from people who attempt these interview process that we have, right? And the evaluation process that we have, right? These are some of this. There are many more of these things that we actually give. And there must be a stark difference in the way we treat the job interviews and the sincerity with which we look at the evaluation of the resources. Now we see this as just a beginning of a journey rather than an elimination round, saying that okay, I'm now going to look back at some of these people, right? So this is something that you can also look forward to, and that's all I had for the day, right?